When we look at a DC motor, we first see the metal protective casing which forms the stator. At one end, we have the tip of a shaft protruding through the casing. We can attach gears, fan blades, or even pulleys onto this. On the other end, we have a plastic end cap with two terminals. We can connect a power supply to these terminals to rotate the shaft. If we remove the casing to look inside the motor, we first find two magnets inside. These are permanent magnets which form a north and south pole. Running through the center of the motor, we see this rod, which is called the shaft. The shaft is used to transfer mechanical energy. Attached to the shaft, we have the rotor. The rotor is made from a number of discs which are laminated together. Each disc has these T-shaped arms cut into them. Wrapped around these T-shaped arms of the rotor are the coil windings which carry the electrical current from the battery. As the current passes through the coils, it produces an electromagnetic field. We control the timing and the polarity of the magnetic field to create rotation. The ends of the coils are connected to the commutator. The commutator is a ring, which has been segmented into a number of plates which sit concentrically around the shaft. These plates are separated and electrically isolated from each other, as well as the shaft. The ends of each coil connect to a different commutator plate. They do this to create a circuit, and we'll see that in detail just shortly. Sitting within the plastic back cover are the brushes, brush arms, and terminals. The commutator plates sit between the two brushes. The brushes rub against the commutator segments to complete the circuit. Electricity can then flow through a terminal, through the arm, into the brush, through a commutator segment, into a coil, then out to another commutator segment, onto the opposite brush and arm, and back to the other terminal. These components give us our basic DC motor. The simplest DC motor has just a single coil. These are a much simpler design. The problem though is that they can align magnetically, which jams the motor and stops it from rotating. The more sets of coils we have, the smoother the rotation will be. This is especially useful for low-speed applications. Therefore, we normally find at least 3 coils in a rotor to ensure smooth rotation. Each coil is positioned 120 degrees from the previous. Between each coil, we find a commutator plate. Each coil is connected with 2 commutator plates. The plates are electrically isolated from each other, except that they are now connected via the coils. So, if we connect the positive and negative terminals to 2 of the commutator plates, we can complete the circuit, current will now flow, and a magnetic field will generate in the coils. The rotor, or armature, is made from multiple discs of iron which are laminated together. Each disc is electrically insulated from one another with a lacquer coating. If the armature was a single piece of solid metal, large eddy currents would swirl around inside. These are caused by induced electromotive force, or EMFs. The eddy currents affect the efficiency of the motor. To reduce the eddy currents, engineers segment the rotor into insulated discs. This way the eddy currents will still flow, but they will be much smaller. The thinner the disc, the smaller the eddy currents will be. The commutator consists of small copper plates which are mounted to the shaft. Each plate is electrically isolated from one another as well as the shaft. The end of each coil is connected to a different commutator plate. In this design, each commutator plate is connected with 2 coils. The plates deliver electricity to the coils. To get the electricity from the battery and into the plates, we have some brushes which rub against the plates. The brush arms hold these in place. When we complete the circuit, electricity will flow into the commutator segments via the brushes, and then it will flow into 1 or 2 coils as a path becomes available. At certain points in the rotation, the brushes will come into contact with 2 plates. This will create an arc, and we get these small bursts of blue light as this occurs. These arcs, as well as friction, will eventually destroy the brushes over time.